introduction to the conference. Welcome everybody for being here. On behalf of me and Alessandro Sperdudi, who is also here online with me. So the two of us, myself, Massimo De Leoni, and Alessandro Sperdudi, are the general chairs of this conference. We are really sorry not to see you here in presence. Unfortunately, it's hard time, and we just have to survive until a solution is found. So what I will do is that in the presentation, since you are not here, you will see once in a while some picturesque picture of Padua. So just to show you what Padua can show as a touristic location. So welcome everybody. This is the Basilica of the Saint of Padua. So we are here with a nice program of 6 days that embrace academia and industry, foster the dissemination among the different souls of our community, and through panels and other workshops that occurred yesterday, we want to facilitate the discussion. And the nice thing is that because it's online, we have a lot of more participants than usual, and this is very nice. And we will see in the conference that the program goes from more industry-oriented to more academia-oriented. This is very nice to enlighten different souls of the process mining community. So you will see that there's been a lot of initiative going on, workshops. There will be 23 research papers presented from today to Friday. A very nice academic keynote by Thomas Seidel, which will be after our introduction. Then we will have 10 industry speakers on Wednesday to show how applicable in the industry process mining is. There will be 1 keynote and 9 speakers illustrating their application of process mining in real world. And on Thursday, there will be an industry panel to facilitate dissemination of information. And you will see that there is much more going on in the community. This has been recognized very nicely, and we thank all of you for being here. We have reached 1,950 participants. And it is a good mix between academia and industry. Indeed, you can see these are the different type of people that register for the conference divided by role. You will see that 39 are academic and 49 comes from the industry. So this is a really good achievement for this. 10% is unspecified because people could also omit specifying what kind of role they played. And it's also nice to see that participants are scattered over the globe. And this picture clearly shows that. You see also the countries that are more, they gave more registrations, Germany, Italy, Netherlands. But it's also nice to see also US that has 10% of the registrations. This is very nice, showing how process mining is also entering very nicely the US market. Then Brazil, India, and many, many more. So this is just a small, you can easily sum up and see that it's a very small number. And this could not have been happening without several people. So I really want to thank PC members, speakers, contributors, every track and initiative. Without them, this could not have happened. And of course, as I said, from today till Friday, there will be 23 research presentations showing the last advances in the process mining world. And for this, I want to thank the PC chairs, Baudewan, Marco, and Mo. Thank you very much for your hard work to select the papers for this research track. Later, Baudewan will continue this presentation, giving some information about some missions and other statistics on the research track. As you know, on Wednesday, we have a very rich industry program with 10 presentations, carefully selected by the industry chairs, Mark Kermans and Marcello La Rosa. Thank you very much for their work, for tuning the presentation with the speakers to make sure that the audience will find it extremely interesting. And of course, I cannot mention everybody that contributed. So like demo chairs, contest chairs, workshops chair, and many other initiatives. So this makes sure that the program is very rich, and you see that it's over 6 days. We attracted a lot of participants, and a lot of people contributed that we had to extend the conference 1 day. Initially, the conference was supposed to finish on a Thursday, but it was so much contribution that we had to extend the conference 1 day. And of course, last but not least, but actually very important, is the thank you for you all participants for being here. Without you, this conference would not be so successful, as I'm confident it will be. Of course, there are many people that you don't see that also contributed to this conference from our side. So I want to thank our department, the Department of Mathematics, all the secretaries, all the technical people that make infrastructure possible to have everything online. Of course, I want to especially thank our secretaries, so Cinzia and Stefania, that took care of all of the contracts, payments, and so on and so forth. It was quite an hard job, especially because you have to consider that most of this was done when when Italy was locked down. So this hard time, they have to deal with all these bureaucratic and financial aspects. So thank you very much for this. Of course, there is also a local organization committee, especially Marilyn and Sahel. Many of you have talked with them in different occasions. Marilyn was more involved in the financial aspect. Sahel took care of all the WOVA configuration and installation and make sure that everything worked very properly. And of course, you don't see, but I already posted this morning, there are people in this moment in a room upstairs, making sure that the booths of the virtual booths of the sponsor are running, and will take care of the academic demonstration speakers. Of course, this great response was also possible by the fact that we had support from sponsors. And so that's why I want to thank all of them for their willingness to contribute to the success of this conference. Both all the platinum sponsors, and thank also to the gold sponsor and to the silver sponsors. And just a quick brief introduction. Many of you, of course, most of you have already seen this system, this WOVA system. Otherwise, of course, you won't be here. But my experience is that I suggest you not to use the mobile app, but you have a best experience, please use the web app. The link is on the website of the conference. And if you are confident to use the Zoom client, at the end of each session and after the video, you have the live stream URL, so you can download, you can log in directly with your Zoom client. You can see here all the attendees, and there you can chat, exchange ideas, know each other, and so on. And very importantly, if you go to the academic demo here, you will be able to connect with the different academic demo presenters today and on Thursday. Today from 2:25 to 2:45, they will be there, willing to show the last academic tools, to show the new advances in terms of implementation, and as a result of very, very strict research. And so you would see here all the different sponsors, all the different demos. You can click, see the video, and have a live chat with those that actually implemented these tools. And then last but not least, you can click on the sponsors, and there will be, similarly to the demo, there will be several sponsors. You can click, see the videos, go to the live, and as if it's a real booth, and there will be people there willing to communicate and discuss with you any question that you have. So from my side, this is all. I hope you to enjoy the conference. And now I will give you the virtual podium to Will van der Rast. because he wants to give his welcome message.
So thanks a lot, Massimiliano. You can hear me, right?
Yes.
Okay, good. Yeah, so also a very warm welcome on behalf of the task force on process mining. So the ICPM conference is one of the activities of the task force. In a minute, I will say something more about this. Just go back, Massimiliano. I will say I'm not controlling my own slides. That's why it's difficult. So, of course, it's great that we have now almost 2,000, let's say, online participants. But of course, I would have rather sit with many of you in a physical room, even if the number would have been, let's say, much smaller. If you go to the next slide, let me tell a bit about the history of the task force, because I think that there are many people registered for this conference that do not know the complete history. So the task force started 11 years ago in 2009. And the goal was to promote the topic of process mining, which was, let's say, virtually unknown at that point in time. Since then, the task force and many of the people listening contributed to that developed. So we wrote a process mining manifesto. We had annual meetings. We also managed to make XCS, so our exchange format, into an official IEEE standard. And because we saw the community growing last year, we decided, well, this is a very good time to start with the conference. So we started with ICPM 2019 here in Aachen. For those of you who have been there, probably remember how hot it was. I think it was 35 degrees, which is not so usual in the place where we are. And here you can see, let's say, the panel, and I would encourage everybody also to attend the industry day and the panel discussion, because I think these interactions are the very interesting part. Next to these activities, of course, there were many workshops. Perhaps I can mention the BPI workshop, which has been ongoing for many years, challenges, etc., etc. If you go to the next slide, Massimiliano. So to tell a bit more about this, the task force, and why am I saying you these things? I'm saying you these things because I want all of the people, let's say, attending this conference also to become a member. Because if you're serious about process mining, you should apply for membership, let's say, of this association. So what you see on this slide is you, first of all, you see the URL of the website. You can go there, fill out a form, and you can apply for membership. What is also this slide is showing is, let's say, the members of the steering committee. You can see that several of the PC chairs are also, let's say, members of the steering committee. If you look at the steering committee, let's say there are a few people from industry, from consultancy firms, but the majority is academic. And we have complemented this year with an advisory board, with, let's say, key people in industry, very much from organizations that apply process mining, like Zalando, BMW, Siemens, etc., etc. We are explicitly, you may wonder, why are there no vendors? Vendors are very important, but we would like to take the commerce out of this. So we are very glad with the sponsorship and support of the, let's say, tool vendors, but of course we cannot put them in a driving position when we are talking about an independent association as ours. There are almost 80 supporting organizations. I think after this conference, this will continue to grow. There are 600 members, so this number can definitely grow a lot. To learn more about the task force, I mentioned the website already. There is also a Twitter account, a LinkedIn group. And if you are registered as a member, you regularly get a newsletter with information intended, let's say, for the process mining community. If you go to the next slide, Massimiliano. So what's next? And I will be very brief here. There will be the award session on Thursday, where I will talk in much more detail about the activities that are being planned for the coming years. But here at the opening, I would like to give some highlights. So in July, the beginning of July, there will be the first process mining summer school. You can see the URL here. The ICPM conference, as probably many of you know, will take place in Eindhoven. Much more detail will be given by Boudewijn on Thursday. And there are a lot of other, let's say, initiatives ranging from contests, workshops, activities around the standard. We will also have a new concept, which is called the process mining circle, intended to link, let's say, more closely to what is happening in industry. If you go to the next slide, Massimiliano. Yeah, so this is my final slide. And of course, I would also like to thank you for participating, for submitting papers, for reviewing. A conference like this has many different chairs. So here you see, let's say, a subset of them. So yesterday we had a super interesting workshop program with many concurrent sessions, and it was a pity that I had to choose, let's say, at any point in time between one of them. So I think that was a very big success, showing how much energy there is in the community. On Sunday, we had a doctoral consortium that I think was also very well visited and very valuable for the PhDs, let's say, working on this topic. There was the award on Sunday. What is coming in the next couple of days is, of course, the scientific program selected by the program chairs. There will be the industry day with more industry practice-oriented talks. There will be demonstration. So it's a very nice and full program. Of course, we had wanted this to be in Padova, sitting there. And the local organization is a bit invisible. So Massimiliano just showed the pictures of the people sitting around the table doing a lot of the work. And it's a pity that they are not more visible. And that's why I'm glad that Massimiliano showed the picture. Of course, we should thank the two general chairs, Alessandro Sperduti, who I think was very important in making this possible at the University of Padova, and also, let's say, securing the resources. But above all, I would like to thank Massimiliano De Leone. We have been drinking a beer and a pizza a few weeks ago in Italy. And like reflecting on this, it has been a bit of a roller coaster. If you plan to organize a physical conference, you move from one location to another location to host more people. And then, let's say, COVID happens. That is not nice. It has been sometimes a bit emotional, but thank you a lot for making this possible. Would like now to pass the token back.
Thank you, Will, for this. So now I want to give the word to Boudewijn on behalf of the PC chairs, so that he can give more information about the part, the research track.
Right, thank you, Massimiliano. I can only join Will in thanking you for the organization. Yesterday was a very smooth day, and I'm looking forward to the rest of the week, especially also the technicians behind the scenes who are taking care of streaming, setting up WOVA, and teaching us how to use Zoom. I have only a few slides on the program and the PC chairs. I would really like to thank my co-chairs, Mo and Marco. They are both here online on the video. So I took some screenshots from the video this morning. We received a total of 72 submissions for the conference, and we accepted a total of 23. And all our PC members, 69 of them came from 32 different countries, and together they provided over 200 reviews. So this was really impressive, but not only the reviews, also the number of comments that we received. So some of you have really engaged in discussions about the contents of the paper, really in-depth discussions on why papers were good or not so good. But in the end, we were very happy with this. And just yesterday, we received confirmation that we will be allowed to select a few papers for a special issue of information systems. So thanks, Marco, for handling the communications around this. So for those of you who have an accepted paper, we'll get back to you with some details on that. Now, as it is customary in conferences, we did make some statistics on the top countries represented in our pool. You'll find that Estonia and Austria are actually the top countries in terms of authors per capita. And both the Netherlands and Israel won when you look at submitted papers per square meters. And then again, Estonia and the Netherlands excelled in the number of accepted papers per capita. So I'm guessing that actually the epicenter of process mining is shifting a bit from Germany to other countries around the world. Although, yeah, in absolute numbers, Germany still wins everything. So you'll find among the 2,000 participants that Massimiliano showed, you'll find that there will be a lot of Germans. But fortunately, also others are represented here. Now, the program for this week, nobody showed that yet. So just to make sure that you've seen this, this is the program. So together we're on the 6th of October. And you see here in red that we'll start with a keynote in a few minutes. After that, there are research tracks, academic demonstrations, panels, industry days, award ceremonies. So it's a really nice full program with a lot of scientific content, but also a lot of social content. Yesterday, we realized that, well, one of the things we miss in a virtual conference is actually the actual beer drinking component. Simply going out in the evening, talking to people that you haven't talked to in a couple of months and enjoying the scenery. And I have to concur, it would have been much better to do this live in Padova in a nice historic city center. But unfortunately, it is what it is. We're probably all locked in either our home office or our actual office. But let's in the evenings also try to make the best of it. So maybe we can meet up for a virtual beer on Skype or Zoom or whatever tools people use these days. So today we have research tracks and a tool demonstration. Tomorrow there's the industry day. I will not say anything about that because this was fully organized by the industry chairs. And then on Thursday and Friday, we have academic sessions. And again, Massimiliano, thanks for making that possible because we accepted far more papers than you initially thought. But it turned out that the quality of the submissions was simply high enough for that to happen. So all that remains for me to do now is to introduce the keynotes of today. So we are very, very happy that we found Thomas Seidel to be willing to deliver today's keynote. As you know, process mining is a research area that's a bit on the border of data mining, data science, process science. Most of us come from a background of a process management community, business process management community, Petrinets community. But more and more, we also see that data mining groups and data mining researchers gain an interest in process mining. And Thomas is one of the researchers in this field who actually recognizes the difficulties in data mining or in machine learning when you look at data coming from processes. So we've asked him to deliver a keynote on this topic. And in his abstract, he describes this as, he starts with the question, like, is it just a variant of the other, or do worlds separate the two areas? And he will discuss the peculiarities in process data and process mining tasks as seen from a data mining perspective. So Thomas, I gladly move the presentation to you, and please go ahead.
Yeah, thanks for the nice introduction, and particularly thanks for the invitation to give this keynote. So I'm just trying to share my screen. I think it's should be this one. Am I right? So you have my slides. Okay. Yeah. Yeah. Again, welcome to this keynote, and thanks for the invitation, and thanks for the introduction, Baudiwein, and the entire PC. I chose the title "Data Mining on Process Data." It is about process mining, but particularly from a perspective of data mining. And what I want to discuss here, I'm sorry. Yeah, no. So this is just the abstract, so you can find it again. What I want to discuss is data mining and machine learning, just as a primer or some recapitulation. And I'm sure I'm carrying tons of owls already here in this section. And then some remarks on process mining and what's the perspective of data mining there. And then I pick a particular aspect, a particular task, finding rare patterns, which is discussed in data mining and also a little in process mining. We have some work there as well on this conference. And in the last section, I took up a question which the organizers posed to me. How is it possible to bridge the mining field? So if you come from the data mining field, or if you come from the process mining field and you want to be successful in the other area, to know something about that. So my thoughts on this will conclude the talk. So I start with the data mining and machine learning section, and machine learning is considered a part of artificial intelligence and goes back to the 1950s, where computers started to imitate intelligent behavior. We saw rule-based systems, logic programming played a big role, and it was on symbolic data and processing symbolic data, and was difficult to bring in numerical data at that time. And later on, so the foundation started in 1950 as well, but there was a flourishing time starting in 1980s, around that, machine learning, where we use data as training data to learn models and to predict the behavior of systems. Or so we have decision trees, support vector machines, probabilistic models were developed, more developed in that time. And another 30 years later, so computer science very fast, but if you see here, it's decades and generations what is needed. Deep learning, which also goes back far in time, but got his flourishing time starting around 10 years back. And we see multi-layer neural networks. So the theory is old, but from that time on, GPUs were very successful, developed in the game industry. So we can get things running, and we can get things running very successful, and they are more successful than other methods. And a lot of studies are around there. So with nonlinear activation functions and so on. So what we also distinguish in machine learning are the different tasks. So we have the descriptive learning, where it's about better understanding the data. So we have the data, we want to find patterns, regularities, irregularities, like outliers, anomalies, and clustering as an example for regular patterns. And this is all about data mining. So we have the data, we want to know something, we want to better understand the data. Then predictive learning is a different task, aims at better forecasting. So we want to do traffic prediction or labeling of unknown objects, spam detection, things like that, fraud detection. And this is called a regression, be it numerically, be it non-numerically. A lot of techniques were developed there. And in recent time, prescriptive learning plays a bigger role. So it's not about better understanding, better forecasting, but it's about better actions. So actions come into play. We want to do predictive maintenance. Something happens then. Autonomous driving as the leading example for that, medical therapies. So this is where artificial intelligence goes into planning, goes into using the knowledge to do better actions. in the end. And there are tons of applications, computer vision, which is needed for autonomous driving, natural language processing. What do we need for any interaction with people, maybe on the phone or on the recognition of any services, providing some information. Customer relationship management as an example for an abstract application where no physics is involved. It's just information about people and their relationship to the companies or our customers, maybe also our suppliers and other related institutions, predictive maintenance, insurance issues, medical therapy planning, and many more applications where we find machine learning, where we find artificial intelligence in our days. So to be a little more technical, we distinguish different problems. So in some cases, or many cases, we have many labels. So we have a lot of training data. We get emails which were annotated to be spam or not. We get patients where the carcinoms were annotated to be malign or benign. So we have the different cases, and we have these concepts given, presented as labels, and we train a model and make predictions based on that. And we call it the supervised learning area. Sometimes we only have some few labels. We focus on a few hidden concepts. So there are a lot of objects and they have concepts in it, but only few are labeled. And we want to learn concepts out of these few labels to make predictions out of that. And there's many approaches for so-called semi-supervised learning. So there is some supervision in the sense that we provide labels, we provide training data, but not all the objects which can be used for learning models are annotated. And we can make use out of that by these techniques of semi-supervised learning. And on the other end of the spectrum, we have no labels at all. We have the data, we have a lot of observations, and either there are no experts who could label the data, or it is too expensive, or it's a new field. So there are many reasons. And we know, or we assume, that there are hidden concepts in the data, maybe many, maybe few, we don't know. We want to find out, are there any concepts? Are there clusters? Are there some regular patterns or something like that? And this is the world of unsupervised learning. A lot of data mining techniques is related to that, just finding out if there is something. And as an example on the next slide, so this is face dataset from Carnegie Mellon University. We have a lot of faces, and we see people are looking to the left, to the right, or straight or upwards, or people wear different colors of shirts, be it black or white or something in between. They wear glasses or not. So there are a lot of concepts, and if we apply a clustering algorithm, for example, we can find clusters, colors of shirts. And we may use that as a ground truth, checking all the other clustering algorithms, but another clustering algorithm will find clusters as a direction of view. And so we see ground truths do not help to evaluate this result, since that's also a very valid thing. And so these clusters are overlapping, so they are not separate. Each of the objects falls into a certain color of shirt cluster and falls into another different direction of view cluster. So these clusterings are existing concurrently, or they compete. So depending on the use case, do we want to find overlap-free clusters, or do we allow for all these clusters concurrently? And if we go back to the semi-supervised, we could make some few annotations to guide the algorithm. We want to see the clusters, the concepts with the colors of shirts, or we want to see the directions of view if we connect these objects with some few supervision interactions. Yeah, so some approaches to use these few labels, to approach these few labels learning are transfer learning, for example. So we, for example, we want to train models to do better predictions or better understanding, whatever, better data mining in a hospital where we have a lot of patients, but no labels, no training data. In another hospital, we have training data. And so why not train a model in the domain A, in the hospital A, for example, and transfer the model to the hospital B? That will not be a 100% perfect, but none of the trained models are 100% perfect in most cases. So we can make use of that and maybe do some additional semi-supervision after that. But transfer learning means we have some training data in one application, train a model, use it for another one. Or another way is active learning. So we have some few labels available and many objects where we don't have the labels. And if we identify where we have the highest amount of uncertainty, then we may ask an oracle, be it a user, be it performing an expensive test to find out the result. Then we can find correct labels here and there. And so increasing the amount of annotated objects. And here's another illustration for that. If you have some few observations, we can have a regression curve here with a bad confidence interval on certain areas and with very good confidence in other areas. And if we now ask the oracle about these areas where the uncertainty is very high, and if we get good answers for that, then we can improve the situation and find better solutions, better predictive models here. A third example I want to show out of the set of many approaches to do few labels learning is data augmentation. So we want to train models. We want to find out the quality of models from some training data, but we only have a small training data set. So why not expanding the training data set, not by just duplicating the data, but by extending it with the same amount of noise, same amount of outliers, same amount of rare patterns. I will come back to that. But in principle, the given distributions should be respected. So we call it data augmentation. We have training data and we want to increase the amount of training data. So that involves training a model with some confidence and generating data out of that. So in process mining, we would call it process discovery. So the play in and then do some play out. And so key is then to control the desired invariance. Do we want to have the same durations? Do we want to have the same noise, or what is it what we want to preserve if we don't want just to duplicate the data? An example, we did that as a collaboration when I still was in Aachen University, was gesture analysis, co-speech gestures. And so the linguists, they complain they only have little training data and it's so expensive to come up with more training data. So our idea was to do some unsupervised analysis to extract frequent patterns to hypothesize gestures. So we observed what does occur frequently, and then we asked the annotators for typical patterns. So they did not annotate the 3D motion capture data and the corresponding videos step by step, or second by second, or frame by frame, but they annotated pattern by pattern. So that was much more efficient and was an example for a few labels learning here. Okay, so that was some aspects of data mining and machine learning, historically, few back in the task of few labels learning. So in process mining, also a short introduction. I will put it into my lectures as well, so that was the preparation. Therefore, we distinguish different types of processes. So there are a lot of continuous processes. So if you call people, we are working on processes, then they say, oh yes, we know we know the chemical processes and technical combustion. So you need partial differential equations, you need nonlinear functions, and you can model that with hinging hyperplanes, for example, or other methods. And it's a lot of control theory. And then we always have to object, oh, no, we are working with event-based processes. So examples are in manufacturing, customer journeys, logistics, hospitals, loan applications, whatever. and the models don't consist of partial differential equations. So a bank transfer is hardly modeled by partial differential equations since it's not continuous. So we have cases, we have traces of events, we need transition systems, for example, Petri nets, or if there's no concurrency, we can use simpler models. But Petri nets is some standard there. So at all, it's automata theory rather than control theory. It's not physical modeling, but it's more abstract modeling. So you know all that in the field, but there are some applications where you need both. So if you ask an expert how to do elevator control, then in our community, so here in process mining, people would say it's about right selection. So you are on the second floor, you want to enter the fourth or the third floor, then you select the target floor, you model that by a state transition system. And so this is the computer science view or process mining view here. States represent floors. We need an alphabet to have the input, so the buttons the passengers press, and the transitions represent rides from one floor to the other. But if you are faced with a mechanical engineer and you ask him for an elevator control, then they smile and say, oh yeah, that's great. What we have to do is to model smooth start and stop. So you want to have jerk-free acceleration. You don't want to perceive that you already moved to the next floor. And you again need partial differential equations, and the ingredients are continuous, second derivatives, boundary conditions from start and stop positions. So if you talk about processes, people have different views and different models and different demands, what they want to do. So in process discovery, in the event-based world, what we are discussing here on ICPM, we have a lot of applications from production and logistics and maybe server operations. And we have state transition models. And we observe what happens by these log files. We have timestamp information. We have case IDs, so the mechanical parts or the customers or the patients in the hospital. And we have events, what happens to the cases in the particular stations. And the goal is to extract some process model. And we first transform the log file into a set of traces. So where we have the case ID, and the case ID is followed by the sequence of events. For example, oh no, sorry, this is not the case ID, this is the number of traces. So we have a lot of traces consisting of A, C, D, E, H. So maybe the 744 or another one, what fits better here. And if you have this trace information, the next step is to come up with a process model like a Petri net or something like that. And then we have different ways to do that. So maybe we find out this model here. So it needs to bring in some concurrency. This is just a linear model. But another outcome of a play method of a process discovery could be this model or that model. And so which one is better? There are different ways and the different algorithms, heuristic mine, inductive mine, alpha algorithm, and all that around. They come up with different limitations, different characteristics. And so if you look into that, then we find that this model here, this lasagne-like model, that just reflects all the different traces, the first trace, the second, the third, the fourth, the fifth. And if you have some deviation in a new trace not seen before, then it's not recognized by this model. A conformance checking would discard that. So this is a case of overfitting. It's too close to the training data and all the errors are in there. So if you have made some mistakes, then it's in the model. On the other end of the scale, there is this overgeneralization case. So we have a start node, an end node, and one single node in between. And every process means we go there to the center, and then we use the B or the F or the C. And so we can model everything. So this every trace is recognized as a good one since it fits to the model. And so we don't want to find the overgeneralization, we don't want to see the overfitting, but there is not so clear which models are the best fit. But this is the world, and this is quite common to machine learning and data mining as well. So there's some commonality. Then we have ingredients of process log files. So if you have a log file, then we want to do some process discovery. Then we look at the attributes. Maybe we have dozens of attributes. Then we want to see, or we want to see timestamps. So date and time, or just the date, or time in milliseconds, or whatever, depends on the process. So if it's in the hospital, it's not milliseconds, but date is too rough. If it's about some loan applications, maybe time is not such important, and date, including months and years. So there are different resolutions possible. Sometimes we don't have the time and the date, we just have the sequence and the ordering. So we come back to that later. Sometimes we also have in the protocol, in the log file, when a certain activity started and when it ends. So it can be seen as two events. The processing starts, processing ends on a certain machine by a certain tool, or we can look at that as a certain individual thing, an extended event or an activity or a period in time. And so we need at least the sequence idea, what was first and what was second. And so we have the ordering in the log file. If we don't find timestamps, then just inherit the order of the activities in the log file. The activities typically are clear. In mechanical engineering, mechanical process, it could be milling, drilling, roughing, polishing, so everything what you can do, physical treatment to the mechanical parts. In the hospital, you have a medical doctor interview, you may have an electrocardiogram, a magnetic resonance, or in the end, the doctor writes a report and you don't have anything, but maybe concurrently or one after the other, or only a single one. So different models are possible. Or if it's about applications, then you have submission steps, assessment steps, approval steps there. So this is in every log file is some activity, something is logged. So if you find nothing in a log file, but this one, then maybe that's already valid. What we need in process mining is cases. So the instances, our patients, our customers, our applications, more abstract, our work pieces, more physical. And sometimes if, for example, if you look at the weather, then it's just the weather. Where are the cases? It's the temperatures over time. But we can find cases. We can look at the different places where the temperature is taken. We can take a look at the different days. So if you have the daily temperature development or the yearly over the seasons, then we can make cases out of that. So it's not so trivial in some cases to identify the cases. And we have the additional resources, which maybe there are not, some equipment information about machines, tools, who operated the process in which step, and some environmental conditions. So why do I explain these very basics you all know from your courses and your research? So let's talk about the timestamps. If you go to the supermarket, you may buy banana, apple, and then you go to the bread, and later with the beverages, and you pick up some beer and the milk, and then you'll find, oh, sorry, I explained the wrong direction. After the bread, I picked up the butter, and then the milk, beer, and lemonades, and in the end, some chocolate. And so it would be very interesting to find out, or to keep this order of picking. So that's interesting. It reflects the buying decisions. If you first take the apple or first take the banana, maybe that makes a difference, or the beer and the lemonade. Did you first think about the beer and you want to have the lemonade in addition, or the other way around? Or which tour did you take first to the fruits and vegetables and later to the sweets? Or yeah, so that's interesting, but regularly not available. So if you are in the supermarket, as long as there are not particular sensors or cameras, you don't have the ordering. What we have available is the registration order. So what you put on the belt and what is taken through the scanner. So that order is registered. That's available, but it's less useful. So in which order you put it on the belt, or in which order it's printed on the receipt, which may differ. I was surprised about that. So to reorder it, sometimes if they print the receipt, interestingly enough. So that's less useful. So what could we do? We are interested in the buying decisions, and one way out is just to disregard the order, to take the order out. And we do frequent item set mining. That is what started in the early 1990s. And people found out algorithm or suggested algorithm to find out what is frequently bought together: beer and butter and bread, or beer and lemonade, and And so this is one transaction. There are tons of transactions for the different customers, and we just disregarded the order. As an example, that orderings are interesting in frequent pattern mining. So let's start on the other end. If you have a totally ordered data like sequences or time series, then there is an analysis around. You can do frequent subsequence search, like the prefix span algorithm or variants of that. Or if it's time series, then there is for decades motif search, and subspace clustering can be applied, dynamic time warping. So there's a lot of proposals. And what we have seen in the supermarket example, we disregard any order. We look at the unordered data and we consider item sets. And the a priori algorithm is a famous algorithm to analyze that. A little more efficient is the FP growth method. So there are algorithms from the data mining area to analyze that. But sometimes, and that's the interesting point, we have partially ordered data. So there is some order. Some of the order of the steps are important to be performed in this order. And for some steps, it's not. So we have concurrent traces or interleaved threads. So if you have a patient in the hospital, then it's very important that the patients get registered in the beginning and that the report is written in the end, and maybe the bill is produced. But in the meantime, if you first have the blood pressure measurement and then the electrocardiogram or the X-ray or whatever, that doesn't matter in many cases. So what is available, and the medical lab works while you have the next discussion with another doctor. So there are concurrent steps, and that was not found in sequence pattern mining, and that was not found in completely unordered item set mining. This is a particular characteristics in my eyes and particular strength of the process mining area. So we have the heuristic miner, the inductive miner, and also from the item sets with some ordering, the CM rules or trace clustering. All these methods are very particular for the process mining and hardly found in other areas where people concentrate on time series, sequential data, or unordered data. So this is something I think if we sell process mining to other domains, we should emphasize that, and we should bring in, or we'll hardly find related work. Maybe there's some, there are the CM rules. I'm not sure whether that guys worked in process mining from the very beginning, or maybe that's a connection there. So totally ordered, unordered, and process mining in the domain of the partially ordered data and patterns. Yeah, another aspect, activities, I talked about that already. We have event types, and the question is, sometimes in the log file, we don't find a good granularity for that. Maybe we have too many activities. Every individual step is recorded, and our process model will be very overwhelming. So many different activities. In another case, we have too few. So there's only start doing something and end, and doing something is not further specified. So we cannot come up with an interesting or useful process model out of that. There is some useful granularity in between, but maybe that's not present in the log file already. So if you have too many, then we could group the steps. So if it's polishing a mechanical part from left to right or from right to left, maybe that doesn't matter, but it is in the log file. So we may aggregate and roll up and in general generalize the steps to have a good granularity of activities. So we build activity types in that case. Clustering may help, so that to have another bridge how to do that aggregation and generalization. If you have too few, then splitting may help diversify, discriminate, but how to do that, and maybe a look into the other attributes may help to support some of these drill down decisions to diversify the data, to find a good granularity. So again, it's data mining methods that may help process mining to, in the pre-processing step, it's not yet finding patterns in the process model, and it's before the heuristic mining, inductive miner, and all the mining algorithms, discovery algorithms start. It's preparing the data to have a good granularity, to have a good database for further process mining. Yeah, so that was the part on process mining. Then I want to dive into a particular problem we developed, or the community developed in the pattern mining, in the item set, frequent item set mining, which can be transferred to process mining as well. And so this particularly is not textbook and not generic concepts, but it's particular research, joint work with Yifeng Lu, who produced most of these slides here, Florian Richter and Ludwig Zellner, who will give some example of our work in the conference on a Friday afternoon session. Yeah, so first, what is low support patterns? So people thought about frequent patterns and starting with the a priori and FP growth algorithm in the early 1990s. There are many developments how to find out frequent patterns, a lot of existing work. Sometimes we have here some frequent patterns. So the blue one, the green one, the yellow one. And so here are some red points. We could consider them being outliers, but they are too close and too many for being just noise or an outlier. So there are 5 observations in that region, in that area of the data space. Maybe that's a pattern, but it's not frequent enough. If we reduce the frequency threshold, then we get too many patterns. If we increase or keep the frequency threshold above, then we miss that pattern. So this is maybe interesting, and they will have some examples in which domains these occur, in the medical and insurance and so on. So the infrequent patterns don't seem important, but the absolute support is not necessarily low. So minor patterns may be nevertheless significant. So if you have 100,000 transactions, then 100 occurrences are already a big number, but it's 0.1%. So it's a very low relative support. But 100 occurrences, maybe it's 100 occurrences of some problem too much. Many applications look at that. So for them, rare patterns are important in scientific and medical domains, vehicle accident data. And so there are some examples here. Rare diseases, for example. So very few people have a rare disease. That's the meaning of the word, a rare disease. But it's not a single person. It's some dozens, hundreds, maybe thousands over the world. It's still a rare disease. But if we have a knowledge about that, if we know more, if we find that, then it's really helpful for society and for mankind. But they don't appear as frequent patterns. Or in car accidents. So there are, in the data, there are road condition information, speed, severity. For example, the pattern that there is a bad road condition and people drove with a high speed and there occurred a serious accident. These patterns may be rare, but should be avoided nevertheless. So we want to find out which places are bad road conditions, and the road condition changes over time. So if it's raining, it's worse than if it's sunny. So we can improve traffic conditions to prevent from high damages and from hurting people seriously. So these are rare patterns. If there are some patterns behind, we want to find out. Another application is synthetic dataset generation. So we talked about data augmentation. And if we want to find out if there are rare patterns, we have to be careful if we increase the dataset that we don't let the rare patterns explode. So they should be preserved as being rare. So knowing what the patterns are in data is important to have a representative bigger dataset for benchmarking and so on. So there are some work existing. So the frequent item set mining workshop from ICPM, then another paper in data mining knowledge discovery and ECMLP KDD. So we picked just a few from the last decade and even before. And the next slides I want to present here are taken from a paper we presented at a data science conference years ago, and some more work on infrequent item sets and patterns and applications for traces and concept drift detection are also referred here. So I already mentioned that Ludwig will present that work on Friday here in the conference. So if we dig into the field, what about the item sets and the frequent item sets, then we look at this Hasse diagram here representing the lattice of power set lattice of item sets. So if you have the items A, B, C, D, E, be it bread, milk, butter, be it patient registration, electrocardiogram, magnetic resonance, and so on, then we rarely find everything in a single transaction or a single trace. And we rarely find nothing. So it's just for completeness to have a complete lattice structure here. But we find some of the single steps frequent. The A is frequent, the B is frequent, C, D is not frequent in this example. So we regularly look at the frequent item sets, and the combination of A and B is frequent as well. A priori and FP growth will find out that. On the other side, we find a lot of item sets which do not occur. So CD is not found in the transaction database or in the trace log file. ABDE is also not found. So these are all the patterns which do not occur in the database at all. And in between, there are some of the patterns we find in the data, but not frequently enough. So AE is there, but it's not frequent. D is there as well, and C, but they are not frequent. So we disregard them in frequent item set mining, but this is the interesting area here. And if now it depends on the data. We have sparse data, we have dense data. Sparse data are transactions in a supermarket. Nobody buys hundreds of different items out of the tens of thousands of items in the supermarket. So we buy dozens maybe. So there's a large number of distinct items, tens of thousands. There are short transactions, maybe a few dozens, and that's already the big weekend purchase. And bottom-up traversal is efficient since we have frequent items only close to the bottom of the Hasse diagram of the lattice. If we have a dense data set, long transactions, for example, the car accident database, then we have a road condition information everywhere. We have some speed information. So we have all the attributes have some values. There's rarely something missing. And we have a small number of distinct items. So there are not such many different road conditions available and so much different speed ranges we distinguish in the database. So the data set is quite dense. Then we have a lot of frequent item sets and only few that do not occur at all. So that's a dense data set, and the top-down method may be more appropriate to find these infrequent areas here. And there are different traversal orders, so we can do breadth first, like the a priori algorithm that starts with with a singleton item sets, then with the pairs, with the triples, and so on. We could do depth first, starting with the A, and then all the combinations with the A. So we go into depth, which is height in this representation here. So deeper into the length of the transaction. So it's the FP growth algorithm works like this one. And we can do a bottom-up analysis or top-down. So how is top-down done? So top-down can be done with a negative database. So what is missing? In ABCD is nothing missing. In ACD, the B is missing, or in BCD, the A is missing. So we can rewrite the algorithms for frequent items as the bottom-up algorithm to come up with a top-down. So a priori and FP growth are working bottom-up. And the rarity algorithm, one of these related work for infrequent item set mining, rare patterns mining, proposes to do the top-down in a negative item set way. So the results learned from that is the breadth first traversal is slower than depth first. So a priori has a big frontier to maintain a lot of candidates, whereas the FP growth has a depth first, so which does not maintain all these candidates in between, but increases the length step by step, is more efficient. Bottom-up traversal is extremely slow when the minimum support is small. So almost all of the existing algorithms. So top-down traversal is better, but the number of frequent patterns need to be huge so that we only dive in not too deep from the top of the diagram. So in reality, in many applications or some cases, we find that data sets are both. They have sparse parts, they have dense parts. So we have areas where only short transactions are frequent, short item sets are frequent, or sometimes long item sets are frequent in one and the same data set. So it would be more efficient to do bottom-up search here on the left part and top-down search here on the right part. And so this toy example, I skip over that. So if you look at the data, then these many short transactions with a low frequency in this case, they are better found with bottom-up traversal, and we should better do a top-down traversal here. In this data, BMS1 data set, explained later, and the mushrooms data set. So the idea we came up with in the Reclo-Miner approach is to do bidirectional traversal. So to combine the top-down and the bottom-up, and the difficult point is to find the split where to switch from bottom-up to top-down. So it's more easy to find here a split point where to find one here. So the data sets from retail data, some BMS, so I need to look up what that was, some mushrooms, chess, and connect with different sizes, so between 10,000 and 100,000 transactions with these few dozens to tens, 16,000 items in different lengths. So we have very short frequent item sets in the retail database, and somehow longer average length in the mushrooms, chess, and connect database. And so the competitors were the Reclo-Miner, the LCM, and the Rarity, proposed in 2004 and 2014 respectively. And so here is the results for the dense data sets. So the chess, mushrooms, like the hospital and car accident, but we did not have data for that. And so we see the rarity algorithm does not perform very well in many cases. Sometimes for small minimum support, it does its work. And the LCM works good, but our Reclo-Miner is not much better in the mushroom data set. It's a little better in chess data, and it does not much significantly outperform the existing LCM for the connect data. But if you look into a sparse data set, then we find that the Reclo-Miner plays its full strength here. So it outperforms all the other methods which suffer from their characteristics. Okay, that was the part on rare patterns, and how to translate that to processes can be seen in our talk on Friday. So I promised to discuss something on how to bridge the mining fields, and I want to come to this point here, close the conclusion of the talk. So bridging fields in general, or bridging fields in data mining and process mining. So is the question how to sell a paper in another neighboring or far field, distinct area. There's a lot of energy if cultures clash. So we saw that in the ancient area where the Greek culture and the Egyptian culture and the Persian culture came across, and sometimes they fight it, but often the scientists united and found, oh, they understood this and they understood that, and if we combine things, so there's a lot of energy and a lot of out of this diversity, and why not exploiting that? Why not supporting that, contributing there to ride that wave if we find one? And it's a regular challenge. So like our group, we origin did a lot of work in data mining, and now we're entering the process mining field, and we have to find that there are differences in the culture. Or it may be yours, if you broaden your focus, you do something deep in the PhD and you want to proceed with an academic career, and then it's a good advice to turn the focus, maybe not completely, but maybe to a slightly different field, or to do something other in a deep way, or so maybe you're faced with that. So what are the basic steps? Important is, in my eyes, to figure out what the other community does understand and what they are willing to accept. So how do they discuss their topics, and how do they talk about their tasks, their solutions and findings? Is there more formal explanations or informal arguments in the papers or in the presentations? Is it more theoretical derivations, more experimental evaluations, more real-world examples or toy examples? And yeah, that's not such black and white as it looks here, since it's not the case that the data mining is only theoretical and the machine learning is only theoretical and data mining is only experimental, or process mining. We find this and that, but maybe in certain directions there are different flavors which prevail. And so in the database community, if you don't have some real world data, then reviewers complain immediately. So you have to come up with some real world data, even if it's not understood well, which is a big thing in the data science area. So the statisticians told me, if they don't know who measured the data, who wrote the questionnaire, who installed the sensors, for which reason they don't want to look at the data at all. So there are so big gaps in the perception of what do we have available as data and as tools. So for example, in privacy preserving data mining, it's nice to have some experience, but if you don't treat their texts and their rebuttals with theoretical basis, with mathematical proofs, then you get your paper rejected immediately. So that's important to know how the community works and thinks and talks about their matters. What success measures are used? Is it quality? Is it efficiency? So in databases, people look at efficiency, and quality is nice. So if you have an SQL query, the result is given. You don't have to discuss the recall of an SQL query. You just have to make sure that it's 100%, what you cannot reach in any prediction task. So often quality is more important in machine learning. But sometimes it's clarity and usability. So in process mining, I assume, if you come up with process models and nobody can understand, they are overwhelming, then that's a big disadvantage. And it's not about efficiency, and it's how to measure that as it's some type of quality, but there's also different types and smells and flavors of quality. And what is the accepted state of the art? Do people insist on the comparison with whatever, or is something too far in the future in the community and they want to see the comparison with something different? Maybe these are questions important to find out by reading papers, by listening tutorials and recent talks about recent results. So present your contributions carefully and also vigorously, both. So sell it. Introduce your concepts in terms of that other world. What are they willing to understand and to accept? Choose the examples from their domains if possible. Translate your task solutions and results, if it's possible, to the other domain. So it's important to understand how do they talk about their tasks, and then try to rephrase your task in that other term. And demonstrate how your concepts overcome the existing solutions. So that's a question about the state of the art. And so I have two final slides, comparable style, how to sell process mining solutions to the data mining community. So you have something important found for processes, and why not submitting that to a data mining venue, data mining journal or conference. Then the first question in my eyes is, what is special about this process data? There are log files, and we see there are timestamps, events, cases, resource information. We had that before. Timestamps may be absolute or relative, date, time, just sequential numbers if there's no temporal information available. So that's valid as well. Events may be symbolic, maybe identified, what we have discussed before. So maybe it's not the existing activity labels, but some generalized or more fine-grained, diversified, maybe points, maybe periods over time as well. There are cases either given, so it's clear, the customer, the patient, the loan application, the book that got landed, or extracted by some data mining. So we need to determine traces. And to make clear that first to yourself and then to the readers of your paper. Then generalize the address process mining problem if possible. So is it something what you develop for a certain application or just for processes, or can it be generalized? So are the solutions limited to process data? Which other contexts can benefit as well? So you come up with a process mining solution, can it be applied to something what does not look like a process in the first sight, but it has some of these characteristics, and so the solution can be generalized. That is what people like in the generic domain like data mining. Then the introduction can be generalized at least until take examples and experimental data from, so that's a typo, don't know what I meant there. And related work is important, as I said, that try to find similar solutions or similar tasks in the data mining literature to show what is already established there. So similar tasks means you found a solution and there is quite a similar solution in the other domain, maybe in data mining, but it's called completely differently. So for example, we did clustering with annotated graphs. So finding groups in graphs with where the nodes have similar attribute values. And it took us too long to understand that this task is already there in network analysis, and it's called community mining or community identification. And so that's one reason why your paper, or our papers in this case, are not cited as highly as it could be if people would find it under this correct word. So if it's about citation, it's one thing, but if it's not accepted, it's another one. And is the solution about sequences or event threads? So there are some topics we could. So I see I'm running out of time. The last slide here is if we have a data mining solution, so we want to sell it to the process mining community, that's our task in our group, is we have to sell the motivation. So we have something clustering, density based and uptake. So what does that mean in the process mining context? Do we find running examples, real examples, toy examples from processes that process people can understand it? What are the pain points in terms of the process mining universe? And then selling the solutions, translate the problem to the other terminology, or the data mining solution to the process mining terminology. Contrast solutions and findings to the state of the art. So again, what is in the other community accepted and present? Okay, don't try to avoid reinventing the wheel. It's not such easy to find what are the wheels that are already invented in the other area there. And finally, the evaluation needs to be solved as well. What is the benchmark data? What is the benchmark methodology? What is accepted in the other area, in the process mining? So what are the repositories, where to take the data that you get really relevant benchmarks out of that? Yeah, and the success criteria, what is measured there? Is it efficiency? Is it quality? What type of quality do people look at? So what does a process mining reviewer want to see in the paper? Okay, so some of these remarks are very generic, some are a little more special. And so this concludes my talk. I talked a little about data mining and machine learning, and the combining, the joint thing between process mining and data mining is we have models in many cases, and we want to find patterns based on models which are trained by given data, be it log files, be it any given training, annotated training data. In process mining, we saw the speciality that there are partially ordered patterns, what is quite unique in the field, I think, and that case identification, activity identification also can benefit from data mining methods. Rare patterns was a particular part. There are regularities in outliers. It's not just noise. It's not just anomalies, but maybe it's a certain type of anomaly we want to avoid, and so we have to identify that in general data, also in processes, to avoid some rare problematic cases. And the bridging question were the last thing. And by the way, I misuse that. If you just finish your PhD and you want to do this bridging, then ask us. We will soon publish an advertisement for that. Yeah, thanks.
Thank you, Thomas. Thank you very much for this interesting talk, bridging a bit the gap between process mining and data mining, or at least identifying where it should be bridged. I see that there is one question popping up in the Q&A, and there is one hand raised. So if people want to ask a question, feel free to type it in the question and answer box or to raise your hands. I'll ask Saket Kishore first to ask the question live. Would you like to do this? So in that case, I can actually unmute you. Let me try to find you in the list of attendees. No longer with us. Then Will, you were the first one to raise your hand, so please go ahead.
Yeah, so thanks, Thomas. I think this is an interesting twist of history. I'm currently sitting in your office, or an office that used to be your office. At the same time, you're using some of my lecture slides in your presentation. So that's I think, very nice. I very much liked your talk, and I think that the connection is interesting. I have multiple questions, but to give the others the floor, I will only ask one. I can ask the other one offline. I liked your comment about partial orders. I think partial orders are like crucial, often because in our input, what our input is partially ordered, right? So I think there's a sweet spot. In the data mining community, there was the notion of episode mining, developed by Heike Manila in the late 90s. And then that was before there was the frequent item sets, and then sequence mining, and then that. And then from Heike Manila, it basically moved to things like graph mining, etc. But in graph mining, the behavior often doesn't play a role. So do you have good pointers, let's say, in the data mining community for mining partial orders, which are somehow different than patterns in a graph, because that doesn't really take into account these behavioral properties?
Yeah, what comes to my mind and what is related there is preference mining. So that's another way where people specify they prefer this place over another one, this hotel over that one, and so you never have a complete order. What you only have all these opinions and all these preferences, and that may help. So this is one domain where I know that that partial orders are used. But it's a different way. It's not a partial order in the sequential occurrence, but it's a partial order in the assessment of the of qualities or so.
Yeah. I'll send the other question via email. Yeah.
Okay. Yeah. Thanks.
Thank you. Marco, you were next, and then I had a question from Jan that I'll also give him the floor after Marco.
Thank you very much, Thomas, also from my side. I'm always interested in this process mining spectrum to understand whether we can also conceive new models or ways to represent the outcome of, for example, discovery, so as to be able then to make this more useful for the end users, right? So something that came really to my mind when you introduced this part on rare patterns is that usually you either look for like frequent patterns, or you look for these rare patterns or outliers, right? So are there languages, or do you think it would be important to study languages to represent models where you can make these different types of patterns coexisting? So that then, for example, when I query the model that I get from the outcome of the discovery process, I can like combine together things that are frequent with things that are infrequent and get like a more like deep understanding of what is going on there.
Yeah, so far I only looked into the algorithm, so the methods behind to identify the patterns, to retrieve them from the data set. But I agree, it's important if you don't want to let people call an API to do that mining, but if you want to have an interactive method and to let them express what they want to know and to express the results in a different way rather than in a table or so, then it's important to have some formal language. But I'm not aware of that query languages or representation languages are there. Maybe knowledge graphs or another mechanism to represent something found in the data. But that's, yeah. So that's my answer. Sorry.
Thank you.
Yeah, you're welcome.
All right, then there was a question from Jan. He posted it in the chat, but let me give him the microphone. Yeah, Jan, please go ahead.
Yes, thanks a lot. Yeah, very interesting talk. I think this discussion needs more coverage in our community. What's the relation between data mining and process mining? And one thing that I was wondering is how can we actually facilitate that people more closely interact, and that this gap is being bridged and knowledge exchange is fostered. So what would be things that you could think about? Could it be a way that we should strive to co-locate ICPM with a data mining conference? Or are there other initiatives and activities that you can think of?
Yeah, that's a good question. So the most simple thing would be to have a workshop on a data mining conference, particularly for process data. I'm not sure where the other way would work. Would work to have a data mining workshop on a process mining conference, but that's a minor solution. To co-locate conferences, yeah, could be a good idea. What other possibilities are there?
So maybe to add to Jan, right? So the Thomas was involved in the organization of the streaming workshop. So that's a specific application area, streaming data, which both in data mining and in process mining communities find their like enthusiasts. And we had a quite nice workshop on Monday on that specific topic. So this was a co-located event. The other way around is maybe happens less frequently.
Right, yeah, so I think that could be another direction to think of, to identify problems where, where both data mining experts and process mining experts would find challenging subtasks, and where the combination of techniques is required to come up with something useful. So I think this is very promising to bring these communities closer together. One thing that I observe in another direction, which is, let's say, a similar observation, is there are various approaches in the computer visualization technique community where people work with techniques for event sequence visualization. Also there, that may be a direction that we want to reach out to. And bringing these fields together would be of good benefit, I believe.
Right, thank you, Jan. Let's move on. There was one question by Donato Malerba. Would you like to ask it live, or would you prefer to keep it in the textual form? I can't find you in the list here, so I'm guessing this will remain textual.
I think I suggest that in general, if it's typed, you just read aloud for the speaker.
Right. So the question that was asked here is, process mining seems related also to multi-relational data mining due to partial ordering. The data mining community has already developed some techniques and tools that could be used. What's your opinion on this, Thomas? What would be the directions of work in this area?
Yeah. Okay, so we looked a lot into multi-dimensional data with a lot of attributes, but multi-relational data where objects are related to each other, not just their attribute values. That is a field I did not look a lot into, and so I make a note. I have to do that if we find partial ordering there as well. But that would be interesting to find out what is what proposals are there, what challenges are solved. Is there something what it was perceived already and could be transferred to process mining or the other way around. So thanks for this hint. So my opinion is also that's a promising area to dive deeper into. And I'm sure we will find results and solutions, at least applications of that. So how do the existing techniques from that area, multi-relational data mining, apply to process mining? Do they work properly, or there are some aspects not yet solved sufficiently? So that's also one observation. If you translate a solution from one area to the other one, then it works well, but not completely. And so there are open questions, there are opportunities. I would encourage that.
All right, thank you. Are there any further questions? Yes, there's a hand going up. Rashid Bekamal, please go ahead.
Hello all. Thank you very much for such a great presentation. I'm working in this field of data mining, and I'm a newcomer to process mining community. So I really enjoyed this talk. And I want to mention that one area that can join these two community, data mining and process mining, would be the transparency, because we have a lot of issues in data mining that we have a very high precision and recall for some data mining projects using machine learning, but we don't know how it happens. So process mining and data mining using event data can help us in this area to present a more transparent method for mining and analytics. I want to mention that. Thank you so much.
Okay, thank you.
Yeah, thanks for that hint. So one of the keywords in machine learning is explainable AI. So people want to understand, want to know what's going on. And in the process mining area, there's a lot of visualizations, of explanations, which are tailored to the application of log files and traces and analysis of that. But why not exploit that and to give the users hints to understand better? And maybe that is what is more missing in the data mining area, and where that could benefit from process mining. That's also what Jan Mendling mentioned, that there's a lot of this visualization and other techniques to find explanations. Yeah, that's a great hint. Thanks, Shiva.